This is Lab 26, Example 6. We want to create polynomials with intercepts at x equals -2, 1, and 6, whose graph matches the graph that's given. This is the graph that is given. So we know that we have our zeros at -2, 1, and 6. So we're going to study this graph and come up with a function that fits it. So first we're going to look at the general behavior of the graph. We see that it starts downwards. It comes from the downward direction, bounces off at this 0, comes up to this 0, bounces off, and then it goes up on the right, and it goes straight through. So because it starts down from the left and up on the right, so I'm going to write it goes from the down and it comes up. We're going to look at our table here. So if we look for down on the left and right, no, that's not it. We have down on the left, up on the right. So we know that our leading coefficient is going to be a is greater than 0, and it's going to have an odd degree. So the information we get just from that part is that a is greater than 0, and we have an n is odd. Essentially, we have an odd degree. So we know that information from that. We also know that for x is -2, 1, and 6, let's see, at -2 it bounces off, so for our 0, x is -2, our multiplicity is going to be even because it bounces off. For x is 1, if you look at it, it bounces off the x-axis without pushing through it. So we know again that we have an even multiplicity. And for x is equal to 6, if we look at the graph, it goes straight through the x-axis and goes up to probably infinity. So we know that this is odd multiplicity. So these are multiplicities, by the way. So now that we know all this information, we can craft our function. So we have y is equal to, we have our a is greater than 0, so I'm just going to assume it's 1 at this point. A is equal to 1. So that means we're just going to start with our zeros. So our first 0 is x is -2, which means we have x minus -2, which is x plus 2. If we were to set that equal to 0, going backwards, we know that x equals -2 has an even multiplicity, so it's going to be squared. I'm going to assume that it could be to the 4th power or to the 6th power even, but I'm going to assume it's squared for right now. And then we're going to move on to our next 0, which is x equals 1, so that's x minus 1, going backwards. We know that it is an even multiplicity again, so again I'm going to assume that it's 2. That's the lowest even integer we have. Well, lowest even natural number. And then for x, our 0 at 6, it has an odd multiplicity, so I'm going to just leave it as 1. And this is, if we graph this, we'll find out that it actually does in fact match this graph. And so this is our function.